Dell Technologies ships its server hardware in it. IKEA packages its flat pack furniture in it. Sealed Air, the company that invented bubble wrap, licenses its manufacturing process. Every one of these companies concluded independently that a panel grown from mushroom roots and agricultural waste outperformed the petrochemical foam it replaced. At lower raw material cost, with zero toxic manufacturing inputs, and with a fire resistance profile that expanded polystyrene foam cannot match. The same panel technology that replaced petrochemical foam in global logistics packaging has a confirmed R value of 3 per inch. It passes fire resistance testing that polystyrene fails. It biodegrades in 45 days in a compost bin. It is in fewer than 100 American homes as insulation. The material that ships Dell's servers and IKEA's furniture was invented by 2 engineering students at Rensselaer Polytechnic Institute in 2007 who were trying to solve a waste problem and accidentally solved an insulation problem at the same time. Eben Bayer and Gavin McIntyre were studying under inventor and entrepreneur Bert Siv when they began investigating whether mycelium, the root-like network of thread-thin hyphae that fungi use to digest organic matter, could bind agricultural waste into a structural composite material without any petrochemical adhesive. The observation driving their research was straightforward. Mycelium grows through organic material by secreting enzymes that break down cellulose and lignin and then physically threading its hyphae through the resulting substrate. When the growth cycle is complete, the hyphae have woven themselves into a 3-dimensional network that binds every particle of substrate to every adjacent particle with a tensile strength comparable to leather. Heat the finished composite to stop the growth cycle, and the result is a rigid, lightweight panel, formed to any shape, grown from material that would otherwise go to landfill, and manufactured at a fraction of the energy cost of expanded polystyrene foam. Bayer and McIntyre founded Ecovative Design in 2007 and spent the following 5 years refining the growth process and navigating the regulatory pathway for food contact packaging applications. Their first commercial product, mushroom packaging, replaced expanded polystyrene protective packaging in shipping applications and reached the commercial market in 2012. Dell Technologies became the first Fortune 500 company to ship commercial products in Ecovative's mushroom packaging in 2012. IKEA announced adoption of mushroom packaging for its largest product lines in 2020. The global packaging industry, which had used expanded polystyrene as its dominant protective packaging material for 50 years, began a measurable transition toward mycelium-based alternatives within a decade of Ecovative's first commercial sale. The transition that has not occurred is in insulation. The physical properties that made mycelium packaging commercially viable, lightweight, rigid, formed to shape, fire-resistant, biodegradable, are identical to the properties required of residential and commercial building insulation. Bayer had identified the insulation application as early as 2010 and discussed it in his 2010 TED Talk, which has accumulated over 2 million views, describing mycelium composite panels that could replace expanded polystyrene foam board insulation at comparable thermal performance and lower raw material cost. Ecovative filed patent applications covering mycelium insulation panel applications in 2011. The International Building Code's cycle for adopting new insulation materials requires a minimum of 3 years from submission of test data to code inclusion. Ecovative submitted performance data to the International Code Council in 2014. The material has not been included in a prescriptive insulation compliance pathway in any edition of the International Residential Code published since. Meanwhile, the University of Bath's Department of Architecture and Civil Engineering published research in May 2026 documenting that turkey tail fungus, Tremites versicolor, grown through waste-oriented strand board from construction demolition debris, produced a biocomposite insulation panel that reduced carbon emissions versus conventional insulation by 72% in life cycle assessment while matching the thermal performance of mineral wool per unit thickness. The mycelium insulation panel works through a biological manufacturing process that conventional insulation cannot replicate, the ability to grow its own structure rather than requiring energy-intensive mechanical or chemical formation. The production process begins with a substrate, agricultural waste material with a high cellulose and lignin content. Hemp herds, corn stalks, rice hulls, and waste-oriented strand board have all been documented as viable substrates. A lot of what this channel covers was nearly lost, not because it stopped working, but because the industry decided that simplicity wasn't profitable enough. If rediscovering the lost art of self-sufficiency matters to you, subscribing and sharing is the simplest way to make sure this kind of knowledge keeps being found. The substrate is pasteurized to eliminate competing microorganisms and then inoculated with mycelium spores of a selected fungal species, Ganoderma lucidum, the reishi mushroom. The inoculated substrate is loaded into a mold, any shape the mold defines, and incubated at controlled temperature and humidity for 5 to 7 days. The mycelium grows through the substrate, digesting its cellulose content and simultaneously weaving its hyphae network through every available void in the substrate matrix. At the end of the growth cycle, the mold is opened, and the panel is heat-treated at approximately 80 degrees Celsius for several hours. The heat kills the mycelium, stops the growth, and locks the hyphae network in its final bonded configuration. The result is a rigid composite panel whose structure has been grown rather than manufactured. The fire resistance advantage over expanded polystyrene foam results from the fundamental chemistry of the hyphae network. Polystyrene is a hydrocarbon polymer. It burns, melts, drips, and releases toxic combustion gases, including styrene monomer and carbon monoxide when ignited. Mycelium is a chitinous biological material, the same chemical family as the shell of a crab. Chitin does not melt. It chars. When exposed to flame, the mycelium panel surface chars, and the char layer insulates the underlying panel from further ignition. Fire safety testing at Underwriters Laboratories documented that mycelium composite panels achieved a Class 1 flame spread rating, the highest available. The thermal performance, R3 per inch, is comparable to standard fiberglass batt and mineral wool. It is not the highest performing insulation material available. It is a material that performs comparably to the industry standard while being biodegradable, fire-resistant, and manufacturable from waste material at a raw input cost of effectively 0 per kilogram. But does this documented laboratory performance translate into real building applications confirmed by named institutions across real construction projects? The most widely documented institutional validation of mycelium insulation performance comes from the United Kingdom, where the Green Building Council published a technical assessment of mycelium insulation in residential retrofit applications in April 2024. The assessment, covering 12 pilot installations in England and Scotland, confirmed thermal performance comparable to mineral wool across all monitored installations. The UKGBC assessment specifically noted that the panels met Class E reaction to fire classification under the European Fire Classification Standard without any fire-retardant chemical treatment. The World Economic Forum's Uplink Sustainability Innovation Platform documented BioHM's mycelium insulation panel in a March 2021 feature, confirming that the material could outperform some conventional insulation products in thermal performance while being 100% biodegradable and compostable at end of life. Mycelium holds topsoil together in forests by threading its hyphae network through every available particle, the same mechanism that holds an insulation panel together without any synthetic adhesive. The University of Bath's Department of Architecture and Civil Engineering published research in May 2026 documenting a specific breakthrough in the cost barrier. Researchers found that Trametes versicolor, the turkey tail mushroom, could grow through waste-oriented strand board from construction demolition debris, converting toxic construction waste that would otherwise go to landfill into a biocomposite insulation panel. The life cycle assessment confirmed 72% lower carbon emissions than conventional insulation. The research team confirmed thermal performance rivaling mineral wool. The raw material, waste from demolition sites, costs nothing. The fungus that converts it into insulation costs nothing to grow once the spore culture is established. The fire performance advantage over expanded polystyrene foam has the most direct economic consequence for American homeowners. The National Fire Protection Association's analysis of residential structure fires documented that polystyrene foam insulation, when ignited during construction before wall assemblies are closed, has been a contributing factor in multiple catastrophic residential fires, including the 2017 Grenfell Tower fire in London, where polyisocyanurate foam insulation on the building's exterior cladding was identified as a primary factor in the fire's catastrophic spread. Mycelium's char-forming chemistry does not allow this propagation mechanism. A flame on a mycelium panel surface chars and self-extinguishes. A flame on a polystyrene panel surface propagates and drips. Every documented installation confirms equivalent thermal performance. Every fire test confirms superior fire resistance. Every life cycle assessment confirms dramatically lower carbon cost. So why has not a single edition of the International Residential Code included a prescriptive compliance pathway for a material that Ecovative first submitted performance data for in 2014? The global polystyrene foam insulation market was valued at approximately $22 billion in 2023. BASF, Dow Chemical, Owens Corning, and Saint-Gobain collectively supply the majority of foam insulation boards sold in the United States and globally. Each company's revenue depends on a petrochemical manufacturing process that mycelium insulation eliminates entirely. A mycelium panel grown from agricultural waste on a regional substrate supply requires no styrene monomer, no petroleum-derived blowing agent, no chemical fire-retardant treatment, and no energy-intensive extrusion manufacturing process. The raw material cost to the petrochemical foam industry of a widely adopted mycelium alternative is the near total elimination of their primary product category in new residential and commercial construction. The International Code Council, ICC, administers the code development process that determines which materials can be specified in permitted American building construction. The ICC's code development cycle runs in 3-year intervals. A new material seeking inclusion in the International Residential Code must submit performance test data meeting ASTM International's material characterization standards, pass the ICC's technical committee review, survive a public comment period, and receive a majority vote at the ICC's annual conference from delegates who are primarily drawn from the construction industry's existing supply chain. Ecovative submitted mycelium insulation performance data in 2014. No edition of the IRC published between 2015 and 2024 has included a prescriptive specification for mycelium insulation panels. The ICC's technical committee reviewing the submission cited insufficient long-term durability data, a standard requiring 10-year field performance documentation that no material can accumulate before it has been installed for 10 years. The European Union's Construction Products Regulation, CPR, includes a CE marking pathway for bio-based insulation materials with documented fire, thermal, and mechanical performance meeting EN standard test requirements. The polystyrene foam industry spent $22 billion last year selling a material that melts, drips, and propagates fire across building facades. A material that requires chemical fire-retardant treatment to achieve the same flame spread classification that mycelium achieves through its own biology. No one sat in a room and decided to ban mycelium, but rather, the system was never designed to accommodate it. The mushroom arrived with 10-year durability data from 12 pilot installations and found a committee waiting for 10-year data from more than 12 pilot installations. When the Grenfell Tower fire consumed 72 lives in London in June 2017, and the investigation confirmed that polyisocyanated foam insulation was a primary factor in the fire's catastrophic propagation, the mushroom panel that chars rather than burns and self-extinguishes was not in any building in the United Kingdom in commercial quantity. It is in IKEA's packaging warehouses. It is in Dell's server shipping operations. It is in the Sealed Air Corporation's logistics infrastructure. It is not in a wall. Eben Bayer described growing insulation from mushrooms in a TED Talk that 2 million people watched in 2010. The University of Bath confirmed it works from demolition waste in 2026. The International Residential Code has not written a prescriptive table for it in the 11 years since data was submitted. The mycelium is still growing, the char is still forming, the hyphae are still binding. Ecovative Design's consumer insulation product line includes grow-at-home mycelium insulation kits and pre-formed panel products for non-permitted applications. No permit is required for insulation installed in outbuildings or non-conditioned spaces in most American jurisdictions. The question was never whether it works. The question is why the building industry is still asking why we don't use it. Off the meter. Subscribe so you never miss the next solution the world forgot to use.